Welcome to Free Coding Academy's Unit 7 review video for Computer Science A. Unit 7 is called Array Lists. Topic 7.1 Array Lists. So array lists are lists that can change size as elements are added or removed during the program. And array lists are part of the java.util package, so you need to import java.util.ArrayList to use them. So at the start of your program, you need to have a statement that says import java.util.ArrayList, semicolon. An array list can only hold reference types, not primitive types, and can be changed after creation. So this describes major differences between array lists and arrays. So if you recall, arrays can hold both primitive types as well as reference types, whereas array lists can only hold reference types and not primitive types. And arrays, their size cannot be changed after creation, whereas array lists, you can change their size. Next, calling new array list creates an empty list with initial size 0. And next, you can't store primitive types directly like int and double in array lists. Therefore, you must use wrapper classes like integer or double, if you recall, are basically the same thing, but they're just the object version of int and doubles. Next, autoboxing automatically converts between primitives and the wrapper classes when needed. So an example of creating an array list, and then you're going to have these alligator brackets, integer with a capital I, and then numbers, that's the name, is equal to new array list, and then you're going to open and close those alligator brackets again, and then in parentheses 10. So this creates an empty array list of size 10 to hold integer objects. Topic 7.2 Array List Methods. So these are some methods you should be familiar with in reference to array lists. So first, dot size. This returns how many items are currently stored in the array list. Next, dot add, and then you're passing in an object as a parameter. This adds the item object to the end of the list and confirms it was added by returning true. Next, dot add, and then you're passing in an index as an int, and you're passing in the object, so whatever object type the array list stores. So this inserts the object at a specific position and shifts the existing items at that position and beyond one step to the right. Next, dot remove, and then you're passing in an index. This deletes the item at the given position and shifts items that follow one step to the left, and it returns the item that was removed. Next, dot get, and then you're passing in an index as an int. This returns the item at the specified position or index. Next, dot set, and then you're passing in an index as an int and an object. So this replaces the current item at the given position with the object, and it returns the item that was replaced. Next, topic 7.3, traversing array lists. So you can go through an array list using an enhanced for loop, a while loop, or a standard for loop with an index. Removing items during traversal can cause skipped elements because the list shifts when an item is removed. So basically, when you're removing an item from the middle of an array list, it's going to shift everything one to the left, because the size just decreased by 1. Therefore, you're going to skip items when you're traversing it by a loop, because it's going to skip one element and go over to the element to the right when you remove them. So this can be avoided by traversing in reverse, so even when you remove an element, it doesn't affect the order in which you're going. And alternatively, this can be avoided by decrementing the counter variable by 1 whenever an element is removed when you're using a loop. Next, array list indices run from 0 to 1 less than the total number of elements. So accessing an index outside this range throws an index out of bounds exception. Changing the size of an array list during traversal with an enhanced for loop by adding or removing elements causes a concurrent modification exception, because if you recall, you cannot modify using an enhanced for loop because that requires the use of index, which an enhanced for loop does not use. So topic 7.5, searching. So first we have sequential or linear search algorithms, and these check each element one by one from start to finish, and it stops when the desired value is found or all elements have been checked. and it works on arrays and array lists of any order, and it's useful for unsorted data or small collections because you're going one by one. Next is binary search algorithms, and these begin at the middle of a sorted array or array list, and they compare the middle value to the target. If the target is smaller, search continues in the left half. If larger, the algorithm moves to the right half. And so it repeats this elimination until the value is found or all possibilities are ruled out. However, for binary search, it requires the data to be sorted in advance, otherwise it's not going to work. Next, statement execution counts can be used to informally compare runtime efficiency between different algorithms, so between these two, for instance. Next, topic 7.6, sorting. So selection sort algorithm, this repeatedly finds the smallest or largest element from the unsorted part of the array. It places it at the correct position by swapping with the current index. Next, it reduces the unsorted region one step at a time. Compared to insertion sort, this builds a sorted portion of the array one element at a time. It takes the next element and inserts it into its correct position within the sorted section. And this is efficient for small or nearly sorted data. And that's it. Thank you so much for watching, and please be sure to check out the video reviewing Unit 8.